Hi everyone, welcome to lecture 12 of CSC 110, and in this lecture we're going to be studying spreadsheets. Okay, so remind you a little bit of what we've done so far. We've been looking at productivity software, also known as Office software, and Office software is not just one program, it's a suite of programs. It's several programs that work together, and every Office suite has some major components to it. One of them is a word processor, which we studied last time, and that's just used for formatting text. Okay, and word processors are pretty easy. Hopefully I showed you some things last time that you may not have known about with word processors that help you make your papers look better, but generally speaking, word processors are pretty straightforward. What we're studying this week are spreadsheets, and if you've never used a spreadsheet before, they are harder to work with. If I just threw a spreadsheet at you and I said start using it, you'd be hard pressed to know what to do with it. So hopefully by the end of this lecture, you'll understand spreadsheets and be able to use them for practical purposes. Next week we'll be studying databases, and databases are by far the hardest part. Okay, and I'm really not going to be teaching you very much with databases. We're just going to be scratching the surface enough that you know what they are, know how to how they interact with the rest of the software, but we're not going to be designing databases together because that's just a little bit too much. Okay, for this course. All right, so spreadsheets, what are they? What are they good for? So basically, they're a glorified calculator for doing bulk calculations on tables of numbers. Okay, so let me give you some examples of where I use spreadsheets. One place that I use spreadsheets is to calculate your grades. Okay, now I could do that through Canvas, but because of the different weightings between things, I actually transfer the data from Canvas to a spreadsheet, and there I can do more sophisticated calculations. Okay, and so when I want to calculate your grades, which is basically a table of numbers, all right, I'll use a spreadsheet. Okay, another thing that you can use a spreadsheet for is something like doing your finances. All right, so every year I've got to pay the taxes like you do, and I have to add up all my expenses, and I have some side business stuff, and I've got to make sure that I keep all that calculated, right? And so I use a spreadsheet to do that. All right, other things that you could use a spreadsheet for is like in physics class or in a science class, you could use it to analyze data. There are just so many uses that it's hard to really quantify them. They're used a lot in business as well. Okay, so rather than trying to go through all the possibilities right now, I'll just give you a flavor for what uses there might be for spreadsheets. Let me start showing them to you, and I think the uses will suggest themselves. Okay, so there are these bulk tables, or it's a calculator which can do bulk calculations on tables of numbers, and you say, well, what does it look like? Okay, so let's switch to a spreadsheet here, and this is just a blank spreadsheet right now. I'll add some numbers to it in a minute, and you can see that it's basically a table, and it's got columns. All right, and so here are the columns, like there's the A column, B column, C column, D column, and so on. Okay, and there are rows. Okay, so this is like row number 1, row number 2, row number 3, row number 4, row number 5, like that. And so basically you have a table of columns and rows, and at the intersection of any row and column, you have what's called a cell. Okay, so what you see highlighted right there is a cell, and every cell has associated with it an address. Okay, an address just basically means how would I refer to that cell? Like, what's its name? Okay, and the name of the address of a cell is basically given by the letter for the column. Okay, so in this case, this cell is in column C. All right, and the number for the row, 5. Okay, and so the address for that particular cell is C5. All right, and in fact you can see it up here. It's a little bit small, but you can see it right up there. Let me see if I can highlight it for you. All right, you see it right. No, I can't quite do it. Okay, so right up in the corner there, you could see C5, and that's because C5 has been highlighted there like that. All right, so every single cell, every single little square here has basically an address associated with it, and it is always the letter for the column first and the number for the row second. Okay, so that particular cell right there is E9. You can see it up there in the cell address box, and you can also just tell because it is in column E. All right, so column E and row 9. All right, okay, so it's always the column letter first followed by the row number. If you said 9E, you say, well, Shouldn't I be able to figure it out from that? Yeah, you can as a human being, but as far as the spreadsheet is concerned, whenever it wants to refer to an address, and you'll see how we use those later, whenever it's going to refer to an address, it always refers to it as E9, okay? And now the kinds of things that you could do with this grid is you could start to put numbers in it and letters in it and so on, okay? Now let me just switch to another sheet for a second. I'll show you how to create sheets in a minute. So you can see here that I've actually filled in some words and numbers there into the spreadsheet, okay? And we'll do something with this in a minute. But right now, I just wanted to show you that what you would do with this. You start off with this blank grid, and you just start putting numbers and words inside of each of the cells there like that, okay? And then you can start to do calculations on them, and that's basically how a spreadsheet works, all right? Now, before we get into doing those calculations, I got to teach you a few things about what spreadsheets expect as far as what you put into those cells, okay? So there are 4 different data types that go into these spreadsheets, okay? So these 4 different types of data are text is one type, okay? Another type are numbers. There are Booleans, and you should remember Booleans from earlier in the class. Those are those true false when we did gates and all that logic, and you thought you were finished with that logic at the beginning of the class. No, logic turns out to be everywhere in computers, okay, and it's coming up again in spreadsheets. And then finally formulas, okay, that's the third type, okay. Now there are 4 different data types that you can put into these cells, and it's important to know the difference between these data types because the spreadsheet's going to treat each one differently. Okay, so let's go back to the spreadsheet and let me show you what I mean by that. All right, so if you take a cell here like that, I just highlighted C4, so I just put my cursor over C4 and highlighted it, and now I can start typing something. And when I type something, I can type, I don't know, like hello, like that. And you'll see that it actually appears in 2 different places. It appears in the cell there like that, and it also appears in this bar up there like that, okay? So we'll see the uses of that bar in a minute. But right now, when I'm typing something into a particular cell like that, it'll appear in the cell, and it'll also appear in that bar up there like that, okay? When I hit enter, it just takes that data and puts it into the cell, okay? So when I click around, whatever cell I click into, you'll see the whatever's in that cell, both in the cell itself, you'll see it's blank, and you'll also see it up here, okay? So the first data type that I put in there is what's called text. It's basically just words, okay? So I just put some words in there like hello, and the words just show up exactly as I type them, all right? And the spreadsheet is going to treat the word differently than it's going to treat those other data types. So let me show you the second data type. The second data type is a number, okay, like the number 7. So I've typed 7 and I hit enter, and you could see already the spreadsheet has done something different with the 7 than it did with the text. The text, it automatically left justified, which means that it pushed it all the way to the left of the cell, okay? But the number, what it did is it put it all the way to the right of the cell, okay? It right justified it. And now you can change that. You can say, well, right justified or left justified. But the mere fact that it treated the number differently than the words, the text, says that the spreadsheet recognizes the 7 or treats the number 7 differently than it treats the word hello, okay? So let me show you some other possible numbers. So 7 is a number. Another possible number, it can have a decimal in it, like 7.5, like that. And if I hit enter, okay, so as soon as you hit enter, it's kind of like putting it into the spreadsheet. Okay, that's 7.5 there. Again, it treated it like a number. Okay, and you can see the 7.5 there, and it's also up there. All right, whatever cell is highlighted, you'll see the what's in that cell, both in the cell here and also in the bar, the display bar up there, okay? So there's the 7.5. So 7 is a number, 7.5 is a number, 7.5.5, if I hit enter, you'll see something weird happened. You think, well, isn't that a number? But it isn't, because a number can only have 1 decimal point. So if you have something like 7.5.5, the spreadsheet says, oh, that can't possibly be a number because a number only has 1 decimal, so it treats it like text. Okay, text is kind of like the default data type. If you can't figure out what it is, what other data type it is, it's going to treat it like text. Okay, so 7.5.5, that's not a number because numbers can only have one decimal in them. And so 7.5 is a number, but 7.5.5 is not. Okay, what about negative numbers? So I could go -7 like that, and I hit enter, and you'll see that it treated it like a number as well. Okay, and I could go positive 7.5, so I could put a plus in front, but when I hit enter, you say, where did the plus go? Well, positive, putting a plus sign there is optional. So the spreadsheet will actually remove the plus if you put it in there. But you could type it in there and it would say, okay, well, you put a plus in there, but I'm going to just treat it like a number and remove the preceding plus. Okay, so basically, a number is, optionally, it starts with a sign, okay, plus or minus, followed by, a bunch of digits. Optionally, a decimal. It doesn't have to have a decimal, but it can have a decimal, followed by optionally some more digits like that. Okay, and that is a number. If it's got more than one decimal, it can't be a number. If it's got a sign embedded in the middle of it, like I don't know, let's do something like 9 minus 8 8 8 7 like that. It's got that negative in the middle. It goes, wait a second, that's not a number, and it treats it like text. So by default, if it thinks it's text, it's going to left justify. In other words, it's going to push it all the way to the left side of the cell. And if it's a number, it's going to push it all the way to the right side of the cell. Okay, so that isn't the full story about the difference between text and numbers, but you're starting to see that the spreadsheet is going to treat them differently, and that's important. Okay, it treats the 4 different data types differently. Okay, so we've covered 2 of the data types. What's another data type? So another data type is a Boolean. And Booleans, if you go back to, when we first started the course, computers just work with ones and zeros, true and false. Boolean is just a logical value of either true or false, okay? And so if you were to type the word true in here like this, like that, it looks like it's going to treat it as text until I hit enter, and then watch what happens when I hit enter. It did something really strange. It, first of all, made it all uppercase, and then it right justified it as if it were a number. And that's because the spreadsheet sees the word true and it goes, oh, you don't want to type the word true. What you're really doing is you're typing the Boolean value true. Okay, and so true and false they're kind of like numbers, but they're special kinds of numbers. They're Boolean numbers, okay, to do logic with them. Okay, and we will be doing logic in a little bit with spreadsheets. All right. Okay, so true is one possible value. What's another one? Well, false, right? So again, if you type false like that, and you say, oh, it looks like I'm typing text, but as soon as you hit enter, the spreadsheet goes, oh, the word false, I recognize the word false. That's a Boolean value, and it treats it like a Boolean. It right justifies it. It puts it all in uppercase, and it'll actually treat false differently than it treats the word hello. Okay, so hello is text. False all in uppercase is a Boolean value. You might say, you know what, I really want to type the word false. I want the text false. You can put a little single quote at the beginning there like that. So this is a single apostrophe, and then you type the word false like that. Oops, false like that. And that basically tells the spreadsheet, you know what, don't treat this like a Boolean, treat it like text. Okay, that's a little bit of an exceptional. We won't need that much, but I just want to show you that, look at that. False there is text. So that's text, whereas false here is Boolean. Okay, that might seem a little confusing to you, but again, the spreadsheet not only needs to know what's in the cell, but it needs to know what type of data is in the cell. And so far we have text, like hello, and it could be any word you like. I don't know, like my grades, like that. Okay, whatever word you like. Okay, that's text. And word, spaces, whatever. Numbers, that's the second type, numbers. Okay, and numbers again can optionally have a sign, like a negative sign there, like that. Okay, and optionally they can have one decimal. All right. Okay, and then there's Boolean, and they're true or false like that, all uppercase. And then finally, there's what's known as formulas. Okay, so a formula is exactly what you think it is. It basically is a way of calculating something. So suppose you want to calculate something like 3 plus 4, okay? Something totally trivial. You probably wouldn't use a spreadsheet for this because it's too trivial to use a spreadsheet just to do simple arithmetic, but it can, well, the way it works is, pick a cell and the first character of a formula must be equals, okay? In fact, if it's any other character than equals, it's not going to treat it as a formula. As soon as it sees the equal sign, the spreadsheet goes, oh, what you're going to type next must be a formula. Okay, so let's type something. Let's type 3 plus 4, okay? Now I put some spaces in there just to make it a little easier to see, but you don't have to put the spaces in there, okay? And you take a look at that and you say, well, what do you think that's going to do? All right, I've got it highlighted there so you can see it. So what do you think 3 plus 4 is going to do? Well, as soon as I hit enter, it's not actually going to print out 3 plus 4. It's actually going to print out the answer to 3 plus 4, which is 7. Okay? And now we have two 7s here. Actually, let me write one underneath. Okay, so I have a 7 here. Let me write 7 here, like that. Okay? And you take a look and you got, oh, I got a 7 on top of a 7. It turns out that this 7 here is a number. And you go, how do I know it's a number? Well, it's a 7 there, and you also look up at the bar up there, and it says 7. And you can see up here at the bar, it shows a 7, okay? So literally, I typed a 7 there. But in the cell above it, I didn't type 7. What did I type? I typed, take a look up here on the bar here like that. I'm sorry, it's a little bit small. Okay, it's a little bit hard to see in the video, but up at the top here, I'll read it off for you. So we're looking at this bar up here at the top, okay, where all the other buttons are, okay. You can see that it says equals 3 plus 4. In the bar up here, it says equals 3 plus 4 because that's what I typed into the cell. Okay, and you could actually see that it's saying 3 plus 4 here because I've got that cell highlighted. But as soon as I hit enter, it replaces the formula with the answer to the formula, which is 7. Okay, and so the lower 7, this 7 right here that's highlighted right now, that's a number in there. And the 7, which is above it, looks like a number, but it's actually the answer to a formula. So the cell that's highlighted right now, which is E12, okay, so you can see here E12, all right, E12, so column E, row 12. If I asked you the question, what data type, what type of data is in E12, the answer would be a formula. And you say, how do I know it's a formula? Not by looking at the answer, which is 7, but by looking up here at the formula bar. It's actually called the formula bar. You could see that it actually says equals 3 plus 4. Okay, equals 3 plus 4. So that cell, E12, actually has a formula in it, and it shows the answer. And down here in cell E13, it actually has the number 7, and you can see the number 7 there. Now, that's a subtle distinction, and it's an important distinction to make, because what you're seeing inside the body of the spreadsheet are not necessarily what you typed there, but what it calculated there. That's like the answers to whatever calculations it's doing. They appear there. And you want to say to yourself, well, but what if I type a formula into a particular cell? How would I know whether there's a number in that cell or a formula in that cell? Like, how do I know what's in a cell? If you highlight the cell and you don't look at the answer in the cell, but you look up here in this that bar there, it's called the formula bar. You see up there, it says equals 3 plus 4. You know that that cell E12 has a formula in it. Okay, so a little bit subtle, but there you could see the difference between the 4 different data types. Okay, sometimes, by the way, I should just mention in brief, some people might say it's 3 different data types plus formulas. I like to think of the formulas as yet another data type. So we'll just call them 4 different data types. What are they again? Well, there's data type text. Okay, and what is text? Text is any data which is just like, it's like the defaults. It's letters, numbers, spaces, special characters, and things like that. And they're used for like column headers, like the names of what's in a column. Okay, and again, you'll see that later. You could label a column with any kind of word that you like at the top, like my grades, or test 1 or something like that, or in the name of a student if you're doing grades or something like that. Okay, basically, text is for human consumption. It's for you to read so that you can interpret the data that's there. That's your first data type. Your second data type are numbers. okay? Because after all, a spreadsheet is a glorified calculator, and so it's got to be able to work with numbers. There's got to be a place where you can put numbers into it, okay? And so you can put numbers in cells. And what's a number? Well, it's optionally a plus or minus at the beginning, and then it's any number of digits with optionally a decimal, okay? Not more than one decimal, because a number, like, what's the meaning of a number with more than one decimal? Okay, so if you have a number with a decimal, you can have that. But if you've got more other symbols, then if you've got any symbol that's not usually in a number, the spreadsheet's going to go, I don't know what this is. It's not a number, so it must be text. If a spreadsheet's not sure what kind of data you just typed in, it's going to treat it like text. Okay, all right, and then there are the Booleans. Okay, now at this point you're like, well, what are Booleans needed for? Like, why would I just want to type true or false into a cell? That seems kind of trivial. You'll see towards the end of the lecture that there's actually a function, an if function, and it's actually very powerful because it's a decision-making function. Okay, and what that function does, or formula. By the way, the word formula and function, they mean the same thing when it comes to spreadsheets, okay? So you might hear me say formula, sometimes functions, they mean the same thing, okay? But anyhow, this if allows you to make decisions. And so you'll see, I'll do an example where if a number is bigger than a certain amount, I do one thing with it, but if a number is less than a certain amount, I do something different with it, okay? And so, yeah, it makes sense to be able to make decisions. Now, if you're making a decision based on something, you have to do a test, and you say, well, is this true or is this false? And as soon as you say, is it true or false? There you go. You're in the world of Booleans. So yeah, they're important, and they're beyond regular calculators. They're more like Booleans are more at the level of programmable calculators rather than your $10 calculator or something like that. Okay, and okay, so we'll see those two, and then the fourth type is going to be formulas, or again functions. The two words are totally synonymous. Okay, and basically functions must begin with an equal sign, and they must conform to a certain format, which I can't quite describe to you right now because it's very complicated. But basically, formulas are used to do calculations. Okay, they say, take this number, take that number, combine them, and you get an answer. Okay, so there you go. Those are the 4 different data types, and it's important to know them because your spreadsheet is going to treat each one differently. Okay, now let's go to the formulas because they're kind of the meat and potatoes of spreadsheets. Okay, so what kind of formulas can you type in there? Well, you could do the any of the 4 general arithmetic operations. Okay, so what are the arithmetic operations? Well, like you can add, and addition is done with a plus sign, obviously. Okay, you could subtract numbers. Okay, and subtraction is done with a dash. Okay, the dash, basically a minus. Okay, you can do multiplication. Be careful, multiplication is not the letter X. Now, you might say, well, why is it not the letter? Why can't I use the letter X? It turns out to be this asterisk right here. Okay, you say, well, why can't I just? Why did they do that? Why not the letter X? Because the letter X could be misinterpreted as a cell address. Okay, so they have a special symbol for multiplication, and it's the asterisk. Okay, basically it's the symbol on top of the 8 key. Okay, if you press Shift 8, you'll get an asterisk. Okay, and then division. Division, there's sometimes like that minus sign with a dot on top and the bottom. I forget the name of that symbol. Okay, but there is no such symbol on the keyboard, and so for division, you use the slash here, usually known as the forward slash. Okay, so you can do just the general arithmetic operations. Also, you know that there's order of operations. So multiplication and division are done before addition, subtraction. Order of operation is obeyed in spreadsheets, just like they are in good calculators. I guess some really old calculators didn't work that way, but modern calculators do. And so if you need to modify the default order of operation, there's also like the open bracket and close bracket. Okay, now you have to use the round brackets for that, and so if you have embedded brackets, you're just going to have round bracket inside of round bracket inside of round bracket. Okay, you can't mix and match like square brackets and curly brackets. Like sometimes in mathematics, higher mathematics, they'll use like different brackets to help you see what's being grouped together better. In Excel and most computer languages, you have to use the round brackets exclusively. Okay, so let me demonstrate some of that for you. Okay, before we move on, you can see here I actually have 3 sheets up, in my spreadsheet right now. And what a sheet is it's basically just like one workspace that you can work in so that you don't interfere with other workspaces, okay? And this sheet has already become kind of messed up. So what I'm going to do is I'm actually going to delete it. And to delete a sheet, there's a menu up here, okay? Now you can't see the menu pop up because of the limitations of the software I'm using to record this. But basically, the sheet here menu, there's actually a place where you can insert a sheet or you can delete a sheet, okay? So I'm going to delete this sheet right now, okay? And it asks me, you can't see the pop-up, but it's asking me, do you want to delete this sheet? And the answer is yes, okay? And these two sheets I created before I started the video so that I wouldn't have to spend time typing things in when I demonstrate with them. But I can create another sheet. I can either go through the menu here and go insert a sheet, or I can just use the plus sign at the bottom here, okay? And that plus sign will actually create a new sheet. And so let's do that. And so you can see now that I've created another sheet, and I can switch between the three sheets by just clicking on there. And you might say, well, what good is it to have multiple sheets? Well, now you could see that I just did it because I wanted to kind of play with a sheet and throw it away. But like for my grades, I have a sheet for every single course. I'm teaching 4 courses, so each course will have the grades on its own sheet, and I can just switch between the courses by just clicking on different sheets here like that. Or maybe you're doing accounting and like you'll have one sheet for your January numbers, another sheet for your February numbers, and so on. Okay, so there's a lot of reasons to have multiple sheets. Okay, anyhow, let's get back to doing arithmetic calculations. The first thing is, pick a cell in which you're going to put your calculation. So I just randomly chose cell C5 there like that. So I just click that. And the very first character that you have to type is always the equal sign, okay? If you type anything except an equal sign, it's going to treat it like text, okay? And then you say, well, okay, let's calculate 3 plus 4 minus 2, like that, okay? Absolutely trivial calculation, I agree, but it's going to do exactly that. 3 plus 4 is 7, minus 2 is 5. And as soon as you hit the enter key, it gives you the answer, okay? Again, highlighting that cell, the cell shows the answer, but the formula bar at the top here, okay, also known as the input line, there's lots of names for this, okay? Basically, that shows the formula that you actually typed, and the answer shows up in the cell. Okay, well, that was kind of trivial. Below it, let's do 3 plus 4 times 2. Okay, now we have to be careful with this because it's not going to do 3 plus 4 first and then multiply by 2. 3 plus 4 would be 7. Multiplied by 2 is going to be 14. Rather, it does respect order of operation, which means that it's going to do the multiplication first. So it's going to do 4 times 2 first, and then it's going to add in the 3. So 4 times 2 is 8, plus 3 is 11. So it'll actually give the answer 11. Okay, and again, to understand what happened there, it didn't do 3 plus, it didn't do an order of 3 plus 4 and then multiply by 2. It said order of operations means I have to do the 4 times 2 first and then add in the 3. Okay, so that's the way you should do it. Again, some old calculators do it wrong, but that's the way it works. Now you say, but you know what? I really do want to do the 3 plus 4 first. Well, then you got to put brackets around it. 3 plus 4 like that, multiplied by 2. Okay, so the brackets there says do this first, do the 3 plus 4 first, and then multiply by 2. So 3 plus 4 first is 7, 7 multiplied by 2 is 14, and you'll see that you get a different answer, okay? And there's the answer, and there's the equation there like that. 3 bracket 3 plus 4, close bracket, multiplied by 2, all right? And the division, I don't know, 14 divided by 2, okay? So the division is done with the forward slash, all right? And there you go, you get 7. It will do fractions, of course. So if you did 13 divided by 2, that's going to be 6.5, not 7, so it'll give you the 6.5. And of course, it works with with negatives, so if you say like 3 minus 4, 3 minus 4 is -1, and so on and so forth, okay? So, it does work just like a glorified calculator, although this really does miss the real essence of what word processors are for. If you were just going to use it for a calculator, and you certainly can, you'd really be missing what spreadsheets are all about, okay? Sorry, I said word processor, I meant spreadsheets, okay? All right, so what's next? Okay, so to really make life interesting, there are these built-in functions. Okay, and these built-in functions, these are kind of like your special keys on a programmable calculator. There's a whole bunch of built-in functions, okay? And these are functions that the spreadsheet knows how to do, and it'll just automatically do those calculations for you. And so let's take a look at some of those, okay? One of them is the sum function, okay? Now what the sum function does is it basically adds up a bunch of numbers, all right, for you. Okay, and we're not going to study all these functions because there's so many. I mean, I don't think anyone knows them all. All right, if you want to see them, you go through what's called the function wizard, and the function wizard will list them all. Okay, I'll show you that in a bit. But the ones that we're going to study are the sum function, which basically adds up a bunch of cells. Okay, the average function, which does an average of a bunch of cells. Okay, so you know, like just a simple arithmetic average. Okay, and then there's the standard deviation, which does a standard deviation of a bunch of cells. And I'll teach you what that is in a bit, because these are heading towards statistics, and some of you are going to need spreadsheets for your statistics class. Okay, so I'm going to teach you the standard deviation, although in stats you're going to learn a lot more. And later I'm going to show you the if function. Okay, but right now we've got these three functions. Okay, and you say, well, what can I use those three functions for? How do they work? All right, so let's switch back here to the spreadsheet, and we have a whole bunch of numbers here. You know, I could create a new sheet, but all I'm going to do is just to show you, I'm going to highlight over all those cells, and I'm going to hit the delete key. And when you hit the delete key, I'm actually getting a pop-up window that says, do you really want to delete all the contents of these cells? And I'm going to say, okay. And there you go. Okay. Now, in a little bit, I'll teach you the difference between deleting the contents of a cell and deleting the cells themselves. This is very similar to the tables in word processors, but you'll see that there's a difference between deleting cells and deleting the contents of the cells. What I did just now is I deleted the contents of the cells, and the way I did it is I just highlighted the cells that I wanted to delete, and I hit delete key. Okay. I could have deleted the sheet and created a new one, but I did want to show you how to delete the contents of a cell. And deleting the contents of a cell are exactly that. Just click and drag across the cells that you want to delete, or even just one cell. You say, I want to just delete that one cell, and then just hit the delete key, and it'll delete the contents of that cell. Okay, back to these functions. So I have, like, let's take a bunch of numbers here, like 5, 6, 7, 4, 6, like that. Okay, and at this point I say, you know what, in this cell right here, so not that cell, but the cell below it there, like that, that's highlighted, I want the sum of all those cells. Okay, well, there's a couple ways to do this. The dumbest way to do it, or the most, I don't know, the most useless way of doing it, I don't know how else to put it, is like you could just say equals 5 plus 6 plus 7 plus 4. This doesn't work because, you know, if it's a short list, then you can go ahead and type them all in. But, you know, it kind of defeats the purpose of the spreadsheet. Okay. Another way to do this is to start off your formula with equals, but now you can reference the values in a cell using the cell addresses. Okay, now what do I mean by that? Well, take a look at this 5 here, the first 5. That 5 is in cell C5. If I actually click on that right there, you'll notice a couple things happen. First, cell C5 got highlighted with this purple highlighting there, like that. And also down here in the formula, it says C5. It doesn't say the number 5, it actually says C5. Okay, and then I can go plus, and then I can click on the cell below it where the 6 is, and you'll notice that in the formula it actually added the address of the cell, not the value in the cell, but the address of the cell C6. Okay, and then I can put plus, so I'm typing the plus, and then a space, and then I click on where the 7 is, and then it puts in cell C7, then plus C8, plus what's next? C9. Whoops, I missed one. Let me backspace over that. C9 plus C10 plus C11, like that. And if I hit enter, that's the sum of all the numbers. Okay, let's look at that very carefully, what happened there. So if I look in there, you'll notice up here in the formula bar, you don't see equals 5 plus 6 plus 7 plus 4 plus 6 plus 7 plus 8 like that. Okay, that's the way I was typing it at the beginning. I said that's not a good way to do it because that's not going to work very well. Okay, instead you'll notice that the first number in the or the first argument in that sequence of numbers that I'm adding up is actually C5. That refers to address C5, okay? That refers to this address right there. What the formula will do, wherever it sees C5 here like that, okay? Well, you can already see the pretty painting as soon as I clicked inside of the input bar here. You can see that you get this, what these colorings are called pretty painting, okay? And you can see here the C5. That C5 says go to cell C5 and replace it with the value 5. Okay, so that C5 there is actually replaced with the value in cell C5. So wherever you see C5 in the formula, it's going to replace it with the value 5. C6, it's going to go to cell C6, which is right here, the orange, and it's going to say, okay, replace the C6 here, the address C6, with the value in cell C6, and so it's going to replace that C6 with a 6. And then C7 is going to be replaced with a 7. C8 is going to be replaced with a 4. That's the green one there. Okay, so you can see here, C8 actually has a 4 in it, so C8 is going to be replaced with a 4. C9 is going to be replaced with a 6. C10 is going to be replaced with a 7. And so C9, C10, and then C11 is going to be replaced with an 8, like that. Okay, so basically wherever you see an address in a formula, it doesn't add the address because that doesn't make any sense. Like, what does C6 plus C7 plus C8, what does that even mean? What it means is that C5 is going to be replaced with the value in C5. C6 is going to be replaced with the value in C6, and so on. And when you hit enter, it gives you the answer. And the answer, summing up all those numbers, is basically going to be 43. Okay? Now, this is a better way to do it. And the reason is that these spreadsheets, they're dynamical, which means if I go into any one of these addresses, like say the 5 there, where I have the 5 in cell C5, if I replace that with a 10, then it'll automatically update that 43 so that it's adding in the 10 instead of the 5. All right, so let me go up here. I'm going to take out the 5 by hitting delete over it like that, okay? And I'm going to replace it with 10, and you could see as I was even doing the replacing, it automatically updates the answer. Okay, so if I can go to any one of the cells here that are referenced in the formula, like where that 6 is. I'm going to take out that 6, so I'm just going to delete it right now. Okay, go over there, like that. I'm going to delete the 6, and I'm going to put in its place, I don't know, 20. And as soon as I hit enter, watch the 48 at the bottom, it updates to 62. Okay, what's it doing? Well, the formula says just go into those cells and whatever values are in those cells, add them up. Okay? If you change the value in a cell, it automatically updates the calculation and puts that value into the cell that has the formula. Okay? So let me hit enter there like that. And so let me show you that with, like, I don't know, I'm going to take out that 6 there and let me put, I don't know, 4 in its place. So I'm deleting the 6 right here. Let me delete that 6. Let me put a 4 in its place. Watch the 62 at the bottom. I'm going to hit return, and as soon as I do, it updates it to 60. Okay. What's happening is as I update the values in the cells, any formulas that reference those cells, any formulas that use the values in those cells, automatically gets updated at the same time. Okay. And one more just to show you. How about we change that 8 to 10? Now, if we change the 8 to 10, that increases the total by 2. That 60 should become 62. So over here, I'm going to get rid of the 8. Okay, I'm going to put 10 in its place, and it updates to 62 like that, okay, as we expected. All right, so this is better because now the formula doesn't really say add up 10 plus 4 plus 7 plus 4 plus 20 plus 7 plus 10. What the formula actually says is add up the values that are in cells C5, C6, C7, C8, C9, C10, C11, and so on. Okay, so that's what this formula is actually doing. But even this is not the best way to do the calculation. Okay, so let me hit enter here. Okay, let me click on that cell and I'm going to delete the formula that's in that cell. Okay, so the way I'm going to do that is I'm going to hit the backspace key, and again I get this pop-up window that you can't see, but it just says, do you really want to delete this? It's just basically it's a pop-up that makes sure that you're not going to delete something that you really want to delete, and I say okay, and there we go. Okay, so I started this whole thing by saying that there's this special function like the sum function. Okay, and so why would the sum function be better? And let me show you how that one works. So to enter in a function, you always start with the equals, but now I'm not going to do any kind of like arithmetic with the pluses and minuses. I'm actually going to type SUM like that. Okay, you can type in lowercase or you can type in uppercase, it doesn't matter, it'll switch it to uppercase anyhow. Okay, so you'll notice what I have there. I have sum, and then I have this open bracket, open round bracket. Okay, and what I'm going to do next is I'm going to click on where the 10 is. That is, I'm going to click on cell C5, and I'm going to click and drag all the way down to C11. All right, so watch me do that, and watch what happens down here in the sum function as I do that. So I'm clicking on C5, and I'm dragging, 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 all the way to C11. Now I'm releasing it, and I'm closing the bracket, and I'm going to hit enter, and you get the answer 62, which we got a minute ago. Okay, now this is a little different. Okay, because if you take a look up here in the formula bar, you'll see that it says equals sum, and I know it's a little small, but let me read it out to you. It says C5 colon C11. So C5 colon C11. Okay, so right in here you have a colon right in the middle there between the C5 and the C11. There's a colon. I'm trying to highlight it, but it's again hard to see. All right. So when you click in the formula bar up there at the top, you'll actually see what the function looks like. Actually, you could see it a little bit better here. It says sum, open bracket, C5 colon C11 close bracket. Okay. So what is this C5 colon C11? So that's actually what's called an array. And an array is actually a block of numbers or a block of cells that are all going to get fed. All the values in those cells are going to be fed to the sum function, and then the sum function is going to calculate the sum of all of those things. Okay, and the way arrays work is C5 is the beginning of the array. Okay, so C5 is the address right up here. C5, that's where the 10 is, and the colon means start at C5 all the way up to and including C11. So C5 colon C11 includes the cells C5, C6, C7, C8, C9, C10, and C11. So C5 through C11 is all of those cells between C5 and C11, including the two endpoints C5 and C11. Okay, and when I hit enter, it simply calculates those. It still updates if I go into the function, into the block here, and I say I change that 4 to, let me change it to 22. And I hit enter, you'll see that the 62 at the bottom updates to 80. Okay, so it works just like I did a minute ago when I was adding all the cells, but now it's doing it through this array here. Okay, let's take a look at that array again, because this is very important that you understand how it works. Equals means what's coming next is a formula. Sum tells you that it's one of the built-in formulas. It's one of those special formulas that spreadsheets know about automatically. By the way, it doesn't matter whether it's LibreOffice or if it's Excel or even if it's the Google Doc sheets. They all understand the word sum, meaning to add things up. They all understand average. They all understand standard deviation and so on. Okay? So sum means add them all up. Okay, give me the total. Okay, it's called a sum. Then there's a round bracket. So between the sum and the array here, C5 to C11, there's an open round bracket. The array is that block of addresses that are going to be fed to the sum function to give you like the total. Okay, and the way the array works is that it's got a starting cell address, C5, a colon, which means everything from C5 up to, and then C11 is where it ends. Okay, and then you have to close the round bracket just to balance them off. And if you hit enter, it calculates the answer, and it gives you that the answer is 80 there like that. Okay, and that's the sum of them all. This is a much better way to do it for a couple of reasons. The first reason is, let me do it over here. If I did equals, and I went through this like before, C5 plus C4 plus C7 plus C8 plus C9 plus C10 plus C11. First of all, that was annoying because I had to do a lot of like clicking, and every time you click, you actually get like the address actually appears in the formula, and then you hit enter at the end, and of course you're going to get the same answer both ways. Okay, so you're going to get the same answer that way or that way. Okay, they both cover the same numbers, but I think you would agree that it was a lot more typing there. Now, if you had, 100 numbers to drag over, or not even 100 numbers, like 40 numbers, which is not atypical for a large class. If I wanted to calculate the grades for a large class, I'd have to add up 40 numbers, calculate the average grade. Okay, well, that's annoying to have to click 40 times, like C5, C6, C7, and so on. Okay, so that's one problem. Okay, well, that's not the case here because all I did was, and I'll do it again. Let me get rid of that function in there. All I had to do was watch how little typing I need to do. I just go equals, and then I type the word sum, and then open bracket, and then I just click and drag across the numbers that I want to do a sum, and I close the bracket, hit enter, and it's done. Okay, because with the array, all I have to do is click and drag across the numbers. It's actually a lot less work. Okay, that's one reason. But there's an even more important reason, and that is if I were to change the structure of the sheet, the array would actually update properly, whereas this other one, the manual way of doing it, would not. And you say, well, what do I mean by that? Well, a minute ago I showed you how to delete the contents of a cell. So you just highlight the cell and just hit delete, and it'll delete the contents of a cell. Okay, and let me put a number back in there like that. Okay, but what if I wanted to delete an entire row or delete an entire column? So it's not the same. If I were to just like highlight this and hit delete, then it would just be deleting the contents of that cell like that. You can see it disappeared. Okay, let me undo that. So Control Z, or just edit undo undoes your last change. Okay, so that's just deleted it, but it kind of left a blank in there. Kind of left like a blank row in there. What if I wanted all of row 8 to disappear? Okay, so if I want all of row 8 to disappear, if I click on that and I hit delete, that doesn't delete the cells in row 8. It just deletes the contents of the cells in row 8 and leaves the cells behind as blanks. To actually delete the contents, what you have to do is you have to go to the menu item here, Sheet. And I know that's a little bit counterintuitive. You say, well, why is it Sheet? Why isn't it under the Edit menu? But the Sheet menu actually has your ability to insert individual cells, to insert rows, to insert columns, to delete cells, to delete rows, to delete columns, to insert sheets, to delete sheets, and so on. Okay, so what I'm going to do is I'm actually going to go delete row, and you can see what just happened. Row 8 disappeared. Let me do that again because I went a little fast. Okay, so watch there. Take a look. See where that 33 is? All of row 8 is going to disappear. All of row 8, which is highlighted right now, is just going to disappear. Now, if row 8 disappears, you might wonder what happens to row 9. Row 9 is going to move up to replace the old row 8. So the 20 is going to go to where that 33 is. The 7 is going to go to where the 20 is, and so on. In other words, everything below row 8 gets moved up one. And row 8 itself gets deleted. Not just the contents of the cell, leaving a blank row 8. Row 8 itself disappears, and then row 9 takes the place of row 8. Row 10 takes the place of row 9, and so on and so forth. Okay? Watch what happens. You'll see that the 33 disappears, and the 20 goes into its place, and the 7 goes to where the 20 is, and so on. Okay? So I'm doing Sheet, delete rows, and there it is. Okay? And now, take a look at your two formulas down here. Your first formula, which was the formula that in terms of sum, in terms of that array, C5 colon C11. Notice what happened to C5 colon C11. It became C5 colon C10. In other words, that block, also known as an array, between C5 to C11, it knows that one of the elements of that block got removed, and it automatically fixes itself. So that, instead of going C5 to C11, it says, oh, you just deleted something in the middle, so now it's only C5 to C10. And it automatically changed it. But this other one over here, notice what it did. It looks really strange. You'll notice there's C5, there's C6, there's C7. And then in the middle here, it goes C, and then it's got this, the number sign ref exclamation point. and then it's C8, C9, C10, and that reference there says unknown reference. That was the old C8. Okay, because the old C8 disappeared, it didn't know what to do there, and so it gives the wrong answer. So basically what I'm trying to show you right now is that when you can use these arrays, you should use the arrays over individual cell addresses. Okay, you could certainly make use of cell addresses, but arrays are much better for this reason. Okay, the sheet, the whole spreadsheet knows how to work with arrays so that it intelligently will add or remove elements to these arrays when you delete or add rows or delete or add columns, but it can't do that with like individual addresses. Okay, like that. So I think I made my point. All right, so let's get rid of this formula here like that, and there we go. Now we have sum, and you can see that it's now the sum of this array here, which has been shortened by 1 because we deleted one of the rows. Okay, let me delete another row just to show you how that works. Okay, so maybe I should just show you that again. Now it's going from C5 to C10. Okay, suppose we delete one in the middle. Okay, so we're going to delete, say, row 8 again, and so I'm going sheet, delete cell, delete rows, and now the array is only from C5 through C9, like that. Okay, it was C5 through C10, but we deleted one of the elements, so it's shrunk itself down to C5 through C9. Okay, so there we go. All right, so that's why these built-in functions that operate on arrays are much better. Okay, I said a minute ago that there were other functions that we wanted to study. Okay, so what are those functions that we want to study? Built-in functions. They're called built-in functions because they're part of all spreadsheets. Every spreadsheet knows about the sum function. And what the sum function does is it adds up all the numbers in the addresses that are referred to by the array. Okay, what does average do? Okay, so first I should mention that there are different types of averages, and you may see this in your statistics courses. The average that most people do are known as arithmetic averages. Okay, and that's basically if you've got like 5 numbers, you want to do the average of 5 numbers, you add up all the 5 numbers and then divide by 5. Okay, that's known as arithmetic average. There's other types of averages. There's a geometric average, okay, and then there's also this harmonic average, and there are actually functions in the spreadsheet for them. But if you want just the old-fashioned arithmetic average, also known as just a plain old average, it's just the word average, okay? Why do I mention this? Because if you search through the function wizard, okay, and you're looking in the function wizard and you ask for the average, it's going to throw all these averages at you. And you go, well, which one do I want? Well, you want the one that's called the arithmetic average, okay? Arithmetic, it's like arithmetic. You just add up the numbers and then divide by the number of numbers, okay? So let me show you how that one works, okay? And so here, let's do it the kind of manual way. And by the way, I'm going to label this row right here. I'm going to label it as the sum, okay? So you see that I just typed in the word sum there in front of the 38, so that later when you look at that 38, you go, oh, that 38 is the sum. Okay, I'm going to label the next one down here the average, like that. All right, and I could do this the old-fashioned way. And you say, well, what's that? Old-fashioned? I mean the slow way. So I'm going to just add up that number plus that number plus that number plus that number plus that number, like that, and then divide by, how many are there? 5, so I'll divide by 5. That is the average, 7.6, okay? And once again, I want to show you why this is disadvantageous to do it that way. Suppose instead of subtracting a row, suppose I want to add a row. Okay, so I've got 5 numbers, but I actually want to add one more number, to this whole array. Okay, in the same place where it says sheet, you can go sheet, insert rows, and then you can actually say insert the row above the 7 row or below. Let me insert it above just to show you what happens. Okay, and so you could see that this was the old row 7 here, and it inserted a row above there like that. Okay, and then over here, let me put a number in there like, I don't know, 8, like that, and hit enter, and you'll take a look here. Whoops, I made a mistake here. Now let me put a number there like that. Okay, if you take a look at this formula here like that, you'll notice something really weird happened. Okay, you might have wanted the average to cover that 8, which is in cell C7. But what happened is that when I inserted that row, it actually the spreadsheet didn't say, oh, I should include that in my average. Okay, so you don't see C7 in here. You see C5, you see C6, you see C8, C9, and C10, but C7 isn't included. And also, if you insert another row, then and you actually add it in, then you should be dividing by 5, not by 6. Okay, sorry, by 6, not by 5. Okay, and none of that is happening because it doesn't know, the spreadsheet doesn't know how to modify this formula the way you've written it here to include the fact that you've added a row. Okay, so let's get rid of that formula. Let's do it the better way, which is to use the built-in function. So we'll go equals average. Okay, you could type it in uppercase or you can type it in lowercase. It'll switch it to uppercase. Okay, open bracket. Okay, so equals average, open bracket, and then click and drag across the cells that you want to do the average of, like that. Okay, you hit enter, and there you go. There's your average. Okay, your average is C5 through C10, so it's the average of all the numbers from C5 through C10. By the way, look at what happened to the sum. It also added in that new row. It used to be C5 through C9, but when you added in that extra row, it goes, oh, you added a row in the middle of my array. I'm going to update my array. Okay, so inserting or deleting rows or columns, the arrays will adjust accordingly. Okay, and you'll see later on that there's a lot of cases where the formulas will actually update their addresses to make sure that they accommodate the changes that you've made to the sheet. All right, so there you go. The sum of these numbers, the sum of all these numbers here is 46, and the average of all those numbers is 7.666666666 like that. Okay, so there you go. There's the average. All right. And the last function I'm going to tell you about is the standard deviation. Okay, and you go, well, what is the standard deviation all about? Okay, so it's here it is, STDEV. Once again, there are different standard deviations. The regular standard deviation, the one that we're going to use, is called STDEV. Okay, STDEV. There it is, STDEV. There are others, and so if you search for different standard deviations, they might come up. This is the one you want. Okay, I'll leave it to your statistics class to explain the difference between the different averages and the different standard deviations. But we're just going to use the arithmetic average and the usual standard deviation. Okay, so what does it measure? Well, first let me show you how the function works, and then I'll tell you what it means. So equals. Okay, begin with equals. STDEV, open bracket, click and drag across the cells that you want to do the standard deviation for, close the bracket. So you see there it's going to do the standard deviation of C5 through C10. You hit enter, and it gives you a standard deviation of 2.2509, blah, 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 blah. Okay, and there it is. All right. One thing about formatting, there are some operations that'll give you lots of decimals, and you say, well, I want to get rid of some of those decimals. All the formatting can be done by buttons up here. So I'll show you a little bit of how to do currencies as well. But I'm going to click on those two cells there and highlight them, and I want to get rid of some of the decimal points. Up along here, you can see that this button will actually remove decimals, and that will increase decimals. Okay, it'll round off, in other words. Okay, so I'm going to just remove some decimals there like this. So I'm clicking the remove decimals, remove, and I'll just do one decimal there like that. Okay, so 7.7, average 7.7, and standard deviation 2.3. Okay, you say, but I want another decimal. Well, then you can add one. Okay, so the plus here will add decimals, and the negative here will remove them. Okay, and there you go. So everyone knows what a sum is. You just add them all up. An average is, you know what an average is. You just add them up and then divide by the number. Okay, but what's the standard deviation? Okay, so this is not a course in statistics, but let's just do a little bit of statistics. Suppose we have the numbers 10, 8, and 6. Okay, 10, 8, and 6. If you wanted to do the average of 10, 8, and 6, what's that going to equal? Well, I think it's pretty obvious. It's going to be 8, but let me just do it using our spreadsheet, because why not? We can. And there you go. Okay, so the average of 10, 8, and 6 is basically 8. Okay, but what is the average of 9, 8, and 7? Well, I don't think it's hard to see that if you take 9 plus 8 plus 7 and divide it by 3, you're also going to get 8. Equals average of this block of numbers there. So 7, 8, and 9 is also 8. So both of those, that has an average of 8 and that has an average of 8. But now let me ask a different question. Yeah, the 8 is in the middle because it's the average. But notice in this one that the numbers deviate 2 above the 8 and 2 below the 8. Okay, so 8 is in the middle, but it can go up as high as 10 or it can go as low as 8. So how much does it deviate from the 8? The numbers themselves, the spread in the numbers. How much does the spread in numbers deviate from the 8? I think it's obvious that it's 2. It deviates from the 8 too. This one, 9, 8, and 7, yeah, 8 is in the middle, but notice that now the numbers only deviate 1 up and 1 down. Okay, so the numbers here, 9, 8, and 7, they're closer together. They have less deviation than the numbers 10, 8, or 6. Okay, and so if I do the standard deviation here, STDEV of 10, 8, and 6, you're going to get 2. Okay, 2. And if you do the standard deviation of these numbers, okay, 9, 8, and 7, like that, and you hit enter, that deviation is 1. Okay, so this set of numbers has an average of 8. This set of numbers also has an average of 8. But this number has an average of 8 with a deviation of 2, a standard deviation of 2. And this set of numbers has an average of 8 with a standard deviation of 1. Okay, so the standard deviation is kind of a measure of how much the numbers deviate from the average. Okay, if the numbers are all very close to the average, they have a very small deviation. If the numbers spread out far from the average, then they have a very big standard deviation. Okay, and you know, again, this is not a statistics course, but you know, people do use this for statistics, and so it's good to know that about the standard deviation. All right, so there you go. We have these built-in functions, sum, average, and standard deviation, and they operate on these arrays, which are these blocks of numbers. Okay, and they will give you the answer for those blocks of numbers. Okay, now let's look a little bit more carefully at how that block of numbers works, okay, because it can get pretty subtle. All right, so let's go back to this spreadsheet here, and you know what, let me just create another sheet. Okay, so I just hit the plus down here and I've created another sheet. The sheet number 3 is still there. I just have sheet number 4 now. And let me just put in some numbers here. 3, 4, 7, 3, 4, like that. And I'm just typing some random numbers like that. Okay, now anywhere on the sheet, it doesn't have to be below them or above them or to the side or anything. I'll just pick this cell right there at random. I can say equals sum, like that. Okay, and now I can pick a block of numbers that is a row of numbers like that. Okay, and let's see what that array looks like. That array looks like C5 through C9. Okay, so that the colon there is usually read through. Okay, so C5 through C9. In other words, all the cells from C5 through C9. And you can see them highlighted here. So there's C5 up here where the 3 is, and C9 is where the 4 is, and C5 through C9 is all of them. So it's going to be C5, C6, C7, C8, and C9. Okay, one of the questions that I give on the assignment is I'll give you an array C5 to C9, and I ask you, what are all the cells that are in C5 through C9? And the answer would be C5, C6, C7, C8, and C9. All right. Okay, so that's one possibility. Let's get rid of that. So I'm going to delete that. Okay, I could also go equals sum, and I can, just pick those two numbers there like that. All right, and then close brackets. And now my array looks like C6 through D6. What does that mean? It means start with C6, and there it is, that's where the 4 is, and go to D6. Okay, that's where the 7 is. Okay, so it's only 2 cells, but still it's an array. It's everything from C6 to D6. Okay, notice that it's the letter that changes because we're going from column to column to column. All right, and not the number that changes. In the previous example, it was the number that changed and not the letter. In fact, you know what? Let me put in another row just to make this as clear as possible. Okay, I'm just typing in some random numbers here. Okay, and then over here I'm going to go equals sum, and then I'm just going to pick that row right there. Okay, close bracket. So we'll take a look there, and you see that the array is C8 through E8. Okay, so that means start at C8 and go to E8. Okay, so the cells that are in that array, C8 through E8, are C8, D8, and E8. Okay, like that. Similarly, let me get rid of that. Go back and show you how the rows work. Sum. And I'm going to pick this row right here. Sorry, column, like that. And you can see now that it's D5 through D9. Okay, it's all in a column, so it's the numbers that change because it's a bunch of rows that are part of the same column. So it's going to be D5, D6, D7, D8, and D9. Okay, that's what's in that array. You can actually cross both rows and columns. Okay, and let me do that for you. So I'm going to start up here. I'm going to click and drag all the way across there like that. Okay, so you could see that I've actually dragged across a bunch of rows and I've dragged across a bunch of columns, and I can hit enter like that. And now you have this array here, C5 through E9, and you go, wow, how do I interpret that? Like if I asked on a test or on the assignment, give me all the cells that form part of the array C5 through E9. You go, well, how do I determine that? So basically, it's going to be all the columns between C and E. So it's going to be all of column C, not all of column C, but column C, column D, and column E. All right. So from C to E is C, D, and E. And it's going to be all the rows between 5 and 9. So it's going to be row 5, row 6, row 7, row 8, and row 9. And so if I ask the question, it would be a very long answer, but I could ask the question, what are all the cells that go into C5 through E9? And the answer would be C5, C6, C7, C8, and C9, D5, D6, D7, D8, and D9, E5, E6, E7, E8, and E9. Basically, it's all the columns between C and E and all the rows between 5 and 9. Okay, so it's not often that you'll see a big block like that which crosses both rows and columns, but you can. Okay, and that's how it works. Another way to think about it is that it is a block, it's square like that, and C5 is the upper left corner here with it's C5. Okay, that's where the 3 is. Okay, and E9 is the lower right corner where that 4 is. Okay, that's E9, and it's all the cells that form the blocks that are defined by that corner, that upper left corner and that lower right corner. Okay, so a little bit subtle, but there it is. That's how that works. Okay, so C5 is up here where the 3 is, and E9 is down there, and the block that's defined by those two corners is basically that array. Okay, so just to make it very, very clear. All right, now the next thing is the idea is that you want to try to minimize the amount of formulas that you type in to do a calculation for a particular sheet. Okay, now the best way to show you what I mean by this is to actually just demonstrate it for you. Okay, so let's go back to the spreadsheet and let's go to sheet number 1 here, because there I actually have a block of numbers that we want to work with. All right, now the way you might interpret this block of numbers is that these numbers are maybe like the sales for a company which sells computer parts. Okay, and so this company that sells computer parts, had January sales. Here are the January sales. Okay, here are the February sales in column D, and here are the March sales in column E. Okay, now every month it sells, this company will sell so many CPUs. So, like in January, it sold $5,354 worth of CPUs. It sold so much money in motherboards. It sold so much in RAM, so much in power supply, and so much in cases like that. Okay, and then similarly for February and so on. Okay, now you look at this and you might say, well, I want to analyze things. Like I want to know the total sales for January. Okay, so these numbers here are basically the breakdown of the sales. So how much money we sold in CPUs, how much in motherboards, and so on. But I say, look, what I want is I actually want the total sales for everything. And so you say, well, that's obviously a sum. So you go equals sum like that, open bracket, and then you just highlight all the cells that you want to add up, and you close the bracket, okay, and you hit enter, and there you go. There's the total. Okay, and so let me just highlight that for you. So it's equal to the sum of C5 through C9 like that. Okay, that block was added up and it gave you the total sales for January. Okay, so there we go, total sales for January. And in fact, as we do this, we probably want to label what this row means. And so this row is going to be instead of sum, I'll just call it total sales. Okay, so there's the total sales, $17,901 for January. Okay, you say, but I also want the total sales for February. All right, you could go ahead and retype everything that I just typed, but this time highlight these cells. But that kind of defeats this philosophy behind spreadsheets, which is to do the minimum amount of work in order to do a calculation. Okay, I mean, it's not that much work to retype the same formula for this column and then that column. Okay, you only have 3 columns here. But what if I had 12 columns, 20 columns? I mean, you'd have to retype the same formula 20 times. Granted, the addresses would be different for the array. They would be different each time because, for this one, for January it would be in the C column, for February it would be in the D column. But spreadsheets allow you to take a formula and copy it with minimal effort. Okay, so let me show you that. I have the formula that I want, calculating what I want in that cell right there. That's cell C11. Okay, so C11 has the total for January. Okay, if I highlight that cell, okay, you'll notice that the lower right corner there, it looks like the highlighting, it's like a square rectangle there, but the lower right corner is a little bit thicker. Okay, it's kind of like a little dot. It's like a square dot there. All right, if you put your cursor right over top of that square dot like this, the cursor changes. So notice that my cursor is kind of like an arrow now, but if I put it right over that square dot, it changes into a cross. If I now click and drag like that and release, it actually did the same calculation for February and March. So I put the formula in for January, but then by doing the special formula drag, it's called a formula drag. Okay, so basically you have to put your cursor right over top of that lower right corner. Okay, and it turns into like a cross there like that, and then you click and drag to the other columns like that, and you release, and it gives you the answer for those other columns. So this is the total for January. That's the total for February, and this one is the total for March. Okay, now when you did this drag, something very special had to happen to the addresses. Let's take a look at those addresses carefully. Okay, if we go here and we look at those addresses, for the January column, the addresses in the array are C5 through C9. Okay, the array again is that C5 colon C9. So when I say array or block, sometimes it's called a block, but it's properly called an array. That's the C5 colon C9. Okay, but C5 colon C9 corresponds to the numbers that we want to add up for January. For February, we don't want C5 through C9. We want D5 through D9. Okay, and you say why? Well, because those are D5 through D9. Okay, if I go in here, take a look at what happened when I dragged the formula over. The C5 through C9, which we had in January, changed into D5 through D9. Okay, so that's very important. That's how spreadsheets work. When you drag the formula to the right one column, all the letters are going to increase by 1. So the letters were C5 through C9 in the C column, but they have become D5 through D9 in the D column because we dragged it over one, and we want that because we want to calculate the sum for all the formulas. For all the numbers in the February column. Okay, well, guess what we get in the March column? It is now not D5 through D9, but it's become E5 through E9. Okay, and so what happens is, and this is a rule for how formulas work, whenever you drag the formula from one column to the right, all the letters in the addresses increase by 1. Okay, let me say that again because that's a little bit subtle. Every time you have a formula and you do a formula drag, one column to the right, all the letters increase by one in the addresses. All right, I'll say it a third time because it is subtle, I agree. Over here, they were C's. When I dragged it from here to there, all the letters in the addresses, not the numbers, just the letters in the addresses, they increased by one. Okay, so increased by one means that they went from being C's here to being D's there like that. Okay, and then I dragged it again, and then it went from being D's to being E's like that. Okay, so every time you drag one column to the right, all the letters in the addresses increase by one. If I were to drag it the other way to the left, then all the letters would decrease, but dragging them to the right, the letters increase. The numbers stay the same, but the letters increase. Okay, and I think you can see the advantage. Again, we only had 3 columns here, so it wouldn't have been a lot of work to type sum equals and then drag, sum equals, or equals sum and then drag, equals sum and then drag. But you know, if I had like 12 months here, okay, January, February, March, April, May, I'd have to do that 12 times. But I don't. All I'd have to do it is once, click, and then drag, 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 and I would do all 12 months. Okay, I would have the total for all 12 months calculated. Okay, so that's kind of interesting. All right, what next? Well, over here, what I'm going to do over here is I'm going to do the same kind of calculation. I'm going to do a total sales here, but now my total sales are going to be total sales of CPUs across 3 months. Okay, so this was the total sales in January, but if I add these 3 up, that's going to be my total sales of CPUs across all 3 months. Okay, so let's do that. So I'm going to go equals sum, and then I'm going to click the January CPU sales, the February CPU sales, and the March CPU sales. I'm going to close the bracket, equals, and there we go. That is the 3 months, all 3 months, CPU sales across all 3 months. Okay, take a look at the address there. It's C5 through E5. So in other words, it's going to be C5, D5, and E5. All 3 of those are added up to give you the total sales for that month. Okay, now I want to do the same for motherboards. I could do the same thing again. I could go equals sum and then drag across the January, February, March, or I could just click on the formula that I already did for CPUs and do my function drag. Okay, now watch very carefully. This is what you do not want to do. You do not want to put your cursor just anywhere and click and drag. That's just plain old highlighting. Okay, and then you release it and nothing happens. What you want to do is you want to highlight the cell that has your formula. Look at the lower right corner of the highlighting right here. Okay, that's the lower right corner, and it's a little tiny square. It's like like the highlighting is a little bit thick there. When you put your cursor over, it turns from your arrow cursor into a crosshair. Okay, a cross like that, and then you hold the click. All right, left click, and then drag, 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 drag. And so what I've done is I've dragged across the motherboards, the RAM, the power supplies and case, and then when I release, it does the formula drag and it calculates the we had the sum for all the CPUs, or the sum for the CPUs across all months. This is the sum for motherboard sales across January, February, March. Same thing for RAM, same thing for power and cases like that. Okay, power supplies and cases. Now, let's take a look at the addresses there. The addresses there were C5 through E5. Okay, when I dragged it down, they became C6 through E6, which makes sense because now we're in row 6. Okay, and then over here it became C7 through E7. Okay, and then it became C8 through E8, and then it became C9 through E9. Okay, so let's go through that series again. So it's C5 E5, C6 E6, C7 E7, C8 E8, C9 E9, like that, and we're done. What happened when we dragged it down? Well, when we dragged it down, we're going from C5, E5, C6, E6, C7. This time, dragging it one row down increases the number by 1. Each time you drag a formula down a row, all the numbers in the addresses increase by 1. Okay? Let me say that again. When you do a formula drag down one row, all the numbers in the addresses increase by 1. Okay, so we've got a couple of rules, and these are good rules because they make life really easy. I didn't have to type that formula in 1, 2, 3, 4, 5 times. I only typed it in once and then a formula drag across there like that. Okay, I didn't type the formula in 3 times there. I just typed it in once and then did a formula drag across there like that. The rule is that when you do the formula drag down, you're crossing rows. You're going from one row to the next row to the next row to the next row to the next row. Okay, when you're dragging across rows, for every row that you drag down 1, you increase the numbers in the cell addresses by 1. Okay, now if you were to drag up, then you would decrease the numbers by 1, but usually you drag down, and so every time you drag down one row, it increases the numbers by 1. You drag down another row, it increases the number by 1 again. Every row you drag down increases the number by 1. Okay, if you're in a column and you drag across the columns here, okay, so we were in C, but we dragged from C to D to E, drag across the columns, then it's the letters that change. And for every column that you drag to the right, it increases the letter by 1. Okay, and so we went from C to D to E like that, okay, with the numbers staying the same. All right, dragging across the rows, we went from 5 to 6 to 7 to 8 to 9 with the letters staying the same. Okay, and you say, well, why is a spreadsheet built like that? Why does it do that? And I think the answer is kind of obvious. It does that because that makes it very easy for me to do the same thing to a bunch of different rows or to a bunch of different columns. All I have to do is do it to one row, do the calculation for one row, and then when I drag it to the other rows or the other columns, it'll automatically update the addresses so that they apply to the other columns. Okay, otherwise you'd have to retype the formula over and over and over again. Okay, so there you go. This is how spreadsheets work. Let's do a little bit more. Let's do average here. Okay, so you might say, yeah, that's the total across the months, but on average, how much do we sell in CPUs? Okay, so January wasn't too good because we sold 5,354. February was a little bit better. We're up to now at 5,643. March was really good. We bumped up to 6,783 in sales. But I'm like, you know what? I really want to know how much what the average is. Okay, so I'm low sometimes, I'm high sometimes. What's my average? And so you're going to go equals average, because we want to calculate the average across these 3 months like that. Okay, and hit enter, and there you go. There is the average of those 3 numbers. So if you were to add 5,354 plus 5,643 plus 6,783 divided by 3, you will get that number right there. Okay? Great. Now what? Well, I want to do the same for motherboards. Don't retype the formula, just do a function drag. And once again, it's highlighted there. Put the cursor in the lower right corner there like that. Click and drag, 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 drag like that. And there you go. You've now calculated it for all 5 categories, for CPUs, motherboards, RAM, power supplies, and cases. Okay. All right. Now these are supposed to be dollars. I'll make everything look nice in a minute, but right now, there's the calculation. All right. What about the standard deviation? That might make sense. Like the standard deviation here. You might say, well, yeah, that's my average, but how much can I expect this number to fluctuate from month to month? I mean, does it fluctuate only a couple $100 from month to month? Does it fluctuate $1,000 from month to month? And that's what the standard deviation gives you. So you can go equals STDEV, and then click and then drag across the 3 months, and there's the standard deviation for the CPUs. In other words, yeah, on average, we will sell $5,926 and some change. On average, we'll sell that much, but you can expect this number to fluctuate as much as $755 above that average or $755 below it. Just like I showed you a minute ago that the standard deviation gives you a measure of how much you can expect to fluctuate around the average. Okay. Well, what's the standard deviation in motherboards and RAM and so on? So again, there you can see the formula is highlighted. I just click on where the cell with the formula, put my cursor in the lower right corner, turns into a crosshairs, click and drag across there like that, and ta-da, there's the standard deviation for all 5 categories. Okay, and I think now you're starting to see that these numbers here, we have a much better sense of like what's going on in our company, because I can talk about total sales, I can talk about averages, I can talk about standard deviations, and so on. Okay. Now, this is more or less all I wanted to really show you in terms of like the arithmetic for this sheet. But I want to show you something else before we move on, and that is how to make a sheet look nice. Okay, because sometimes these things are used for presentation. So yeah, that's $5,354, but that doesn't look like currency. Okay, and so what you might want to do is you might want to highlight all the numbers here like this. So I'm just going to highlight all my numbers here like that, and even a little bit more. It doesn't matter, some of the blanks as well. And you'll notice up here there's this icon right here. Okay, I don't know if you can see it. You can't see it too well. What it looks like is basically like a green dollar bill with some coins beside it. Okay, in other words, it looks like money. Okay, and I'm sure if you've got Microsoft Excel, it looks different in Microsoft Excel. Like in an older version of LibreOffice, it used to be like a dollar sign and stuff like that. But you've got the sense that it's money. Okay, so what do you think it does? It formats things like money. So if I click on that, everything now gets formatted as money. Okay, so there you go. It's rounded off to 2 decimals, and it's made to look like money. Okay, great. What else could I do here? Well, it's nice as a table, but maybe what we would like to do is give the table a heading. Okay, and you can do that. You can actually change the sizes of rows or columns. So here's a row like that, and I can expand the size of that row by putting my cursor between the 2 and the 3 here, row 2 and row 3, and then I can click and I can make my row bigger or smaller like that. Okay, and then across the top here I can just take a bunch of cells here like this, and I could say, you know what, I'm going to put a title across here like that. Okay, and there's this there's a I don't think we really need that icon. We could just type in here total sales like that. Okay, and that looks terrible, right? Because it's small. But what we can do is we can go there and we can change it to a much larger font. Okay, so like size 8. Whoops, I didn't highlight it. Now it'll change. Okay, well, that was too big. Okay, so let's make it, I don't know, maybe 54. That's still a little bit too big. Let's shrink it down a bit more, 40. Okay, like that, and there we go. Okay, so we've got the total sales across there like that. All right, and so I could put a title on it, and then the other thing that we could do is we can actually make a graph here. Okay, and so there's different types of graphs that you can make, but the graph that's very good for this particular type of sheet is basically a bar graph. Okay, and so to do that, what you can do is you can actually highlight not only the numbers that you want to go in the bar graph. So this is part of our analysis. We won't include that in the graph. Okay, but you want the numbers, and then you can also highlight the columns there. Okay, and the row. Because if you do that, it'll actually incorporate those text fields as part of the labels in your graph. Okay, now the next thing you need to do is say, I want to make a graph. Okay, and you say, well, how do you do that? Up here, graph or a chart, you can see this thing that looks like a pie. Okay, and it's got colors in it like that. Again, it's a little different in Excel and whatever other spreadsheet, but generally, it says insert chart like that. And if you click on that, it's going to bring up a wizard. Okay, so I'm going to click on that, and up comes a wizard. Now, you can't see the wizard. Okay, what you can see though is the graph that results from the wizard. Okay, so rather than me switching to the wizard, let me just show you what different options, what happens when you pick the different options. So right now I've got my wizard on a bar graph. Okay, so I can pick a column graph. A bar graph looks like this. Okay, it just puts them on the side. So they're really the same graph, but one is the other way around. Okay, so you can't see this wizard window that I'm doing. Not a big deal. It just has a bunch of different options. Your first option is column, like this. Your second option is bar, and then there's others which are not appropriate, but I'll show you. Like this will look awful, but you could do like a pie chart, although it doesn't really make too much sense in this case. And then there's like an X and Y scatter chart like this, okay, which is basically like X and Y points. Again, that doesn't make too much sense in our case, but there it is, okay. So let's do a column graph like that, and you could see here that in the column graph, you've got basically your CPUs, motherboards, RAM, and so on, okay. In the next, 1 second here, in part of the same one, I like the stacked version, and so this is basically known as a stack, okay, version like that. Now, what you're seeing right now is you're seeing the height of this column here. The height of the column is the total sales in CPUs, and the blue is how much sales there was in January. The orange here is the CPU sales in February, and the yellow here is the CPU sales in March, so that the whole graph here, the whole height of that column, is basically your total sales of CPUs for January plus February plus March. Okay, same thing for motherboards, same thing for RAM, same thing for power supplies, and same thing for cases. Okay, there's another window here, and this is basically, I'm going to go into the next step of the wizard. So this is in window number 2 of the wizard. It actually says, do you really want the CPU motherboards down here and the months up here, or do you want to switch them? So you can actually switch them and take a look at this. So this is the other way around. Now the total height of this column is the total January sales, and the blue is the CPUs. So you can see here on the chart here, it's the CPUs, okay? So in January, the blue is the CPU sales, the orange is the motherboard sales, the yellow is the RAM sales, the green is the power supply, and the brown is the cases. Yeah, okay. And then in February, same thing. The total February sales, that's the height of this column, okay. And the blue is how much of that total height is from CPUs. The orange is how much is from motherboards. The yellow is from RAM. The green is from power supplies, and so on. So you could switch, and it depends how you want to analyze the data. Do you want to see the total sales for January broken down according to CPUs, motherboards, RAM, power supplies, cases, or do you want to see it the other way around? And the other way around is the total CPU sales broken down by January, February, March. The total motherboard sales broken down for January, February, and March. Okay, it depends what you want. Okay, so let's say that we want the total sales for per month broken down according to the various categories. Then we'd want this. Okay, because the height of this column is the January sales. The height of the February column is the February sales, and the height of the March column is the March sales. So you could quickly look at this and you can go, oh look, March was much nicer than had better sales in March than we did in January or February. Okay, and there's some other things you can change in the wizard. Those are the only important things, really. The other stuff are like, just some kind of eye candy about like how you want to label some other parts of the graph here. Okay, so they're not that interesting. So I'm just going to say finish. And there it is. Okay. The only problem is that my graph is actually covering all my data. All right. So what I'm going to do is I'm going to click off the graph first, and then click on it again, and I'm going to shrink the graph down. Okay. And grab one of the corners. I'm just grabbing a corner and shrinking it down, and I can now move it down here like that. Okay. So there you go. All right. So there's my numbers from before, and then right below it I have my graph there like that. Okay, so you can make graphs. And again, the way you make graphs or charts, synonymous again, graph or chart, is it's this button right here. And it's kind of small in the video, but it's basically looks, if you look at it close, it basically looks like a pie, which has like a big red piece, and then there's like different colored slices out of it. Okay, and if you put your cursor over top of it, it will come up. It'll bring up like a tooltip help. It just basically says insert chart, so you know to insert a chart. By the way, just like with word processors, anything that you can do through the buttons here, you can also find in the menus. Okay, so there is a place in Excel and in LibreOffice Calc here where it allows you to go to do an insert chart under the insert menu. Okay, so great, there you go. There's part of how this spreadsheet works in terms of addresses and arrays. Okay, there's still a little bit more. Okay, so let's go on. All right, so all right, great. Oh, it's gotten pretty dark. Sorry about that. So you know, the next thing we're going to study is the business of what happens when you don't want a cell address to change. Okay, so if you don't want a cell address to change, you can actually make use of a $ in front of an address. Okay, so take a look at this this right here. So basically here you have like a $ B1 and a $ B3, and you wonder, what is that $ doing in front of the B? And let me actually show you. It's easier to show you than to try to explain it to you. Let's take a look at this graph right here, or sorry, this sheet right here, and suppose I want to actually do something like taxes over here, or sales tax, like this. Okay, so sales tax. Sorry, let me finish that up. Okay, so you know that when you sell stuff, you have to pay a certain percentage to the state as sales tax, and usually your sales tax is like 8%. Okay, and so over here in this cell right there, I'm going to put 8%. Okay, now you could write 8% as 0.08 like that, and that's certainly fine. Okay, like that, 8%. Or what you can do is you can format it as a percentage, because there's a button here. This is right beside the currency button. It's a % button. If you click on that, you'll see that it converted it to 8%. Okay, but basically 8% is 0.08. All right, so now 8% of what? Well, let's do 8% of the total sales, because that's what we have to pay to the state government. Okay, I forget. I think in New York State it's actually 8.5%, but it doesn't matter for the purposes of this demonstration. I'm just going to do 8%. Okay, and now what I'll do over here on the sales tax is I'm going to go equals, and then I'm going to click on this cell right there, because that's the total. G5 has the total sales of CPUs, and then I'm going to multiply that by my 8%. Okay, like that. And I just clicked on K4 and it brings up that that address there. And so let me highlight those. So I put my cursor inside the input bar up at the top here for the formula bar here, and you could see there's my formula. So it's equal to G5. So G5 is that value, 17,780. Okay, the value that's inside the blue box, multiplied by K4, which is the value which is inside of the red box. Okay, and you go, great. If I calculate that, that's how much we're going to have to pay in sales tax for CPUs. So the CPU sales tax, the sales tax on all our CPUs over all 3 months is going to be $1,422.40. Okay, and you say, wonderful, let's do that for the motherboards, let's do that for everything else for the RAM and so on. So what you do is you put your cursor here at the lower bottom corner, and you click and you do the formula drag, and you release it, and you get an unexpected answer. You get, wait a sec, how can you have sold $8,104 in motherboards, but you don't have to pay any taxes on it? That makes no sense. You just sold $8,104 and there's no sales tax. And there's no sales tax on the RAM, on the power supplies. Something went wrong. Okay, well, it worked for this one. It worked for the CPUs, but it did not work for the RAM. And let's see why it didn't work for the RAM. If I click, and I'm putting my cursor inside the formula bar here and the input line, click on that, and you can see that now it highlights the motherboards. Okay, the total sales in motherboards here, that 8,104, that's the blue, multiplied by, and you see what happened here, it says K5. Well, a minute ago, when we were doing it for the CPUs, it said K4. But what happened was when we dragged the formula down one, that K4 became K5. And take a look at what's in cell K5. K5 is a cell with the red outlining there. It's blank, and blank is like 0. So that's like taking the value in G6, which is 8,104, and multiplying it by 0. Okay? Well, that's no good, because basically that means that you're going to get 0. You didn't want that, really. What you wanted was, instead of K5 here, you wanted K4. Now, you can manually go in there and say, you know what, I'm going to change that K5 to K4 like that. And then it gives you the right answer. Okay? But that's kind of annoying, because you're not only going to have to do that for the motherboards, you're also going to have to do it for the next one, because take a look at what happened there. It's even worse. See, because I dragged it down 2 rows, it's now 2 rows below that 8%. Okay? And so it's getting worse. And you say, well, is there some way that I could just stop that that number there from changing when I drag it down? Okay? So once again, let's go back to up here and drag it down, just so you can see where we're at. Here it was K4, but here it became K5. Whoops, K5. Sorry about that. Let me do this again. So it was K4, and that was right. But then it became K5, and that was wrong because it was down by 1. You wanted K4. Then it became K6, and that's even worse because now it's down by 2. It was supposed to be K4, but now it's K6. Okay, and now it's K7, and now it's K8. Well, it's doing exactly what spreadsheets are supposed to do to the addresses and formulas when you drag them down a row. It's supposed to change the numbers. And it doesn't know that you don't want that number to change. Okay, so you could tell it, don't change the number when you drag it down. And this is how you do it. Let me get rid of these. Okay, let's go back to this here. And you can see here I've got K4. The problem wasn't the K that was changing. Well, first of all, the G5, you want that to change. You want that to become G6, G7, G8, because that'll refer to the total sales for motherboards, RAM, and so on. It's the K4 that's the problem. And it's not the K in the K4. It's the 4 in the K4. You don't want that 4 to change to a 5, to change to a 6. And so the way to stop that from happening is, in front of the 4 in the address, you can put a $sign like that. Okay? Now let me just show you that formula. Take a look at that. It's no longer K4, it's $4. And you say, well, what does that $sign do? The $sign is actually going to stop the 4 from changing when I drag this down. Okay, so let me enter that. Let me do now a click and drag down. So I'm doing a formula drag down, 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 down like that. And you'll notice that this time it did work. Okay, so there's the sales tax for CPUs. There's the sales tax for motherboards. There's the sales tax for RAM, sales tax for power supply. And you say, well, what happened here? Well, there it's K4. The address is K4. It's $4. So when I drag it down by 1, it's still K4 because the $sign stopped the 4 from changing. Okay? And it's still K4 because the $sign stopped the 4 from changing. Whenever there's a part of an address that changes, when you drag it, either from row to row to row or column to column to column, and that you don't want that part of the address to change, you put a $sign in front of it. Okay? Here it was the 4 that was changing. All right? Let me do this for you again. So I'm going to redo the whole demonstration over here. I start right from scratch. Equals sales tax multiplied by the percentage, the sales tax percentage, like that. So there's the formula. Okay? I dragged it down, but when I dragged it down, I noticed that the K4 became K5, became K6, became K7. And I say to myself, I don't want that 4 to change. But it did. It became a 5. So I say to myself, I want that 4 to stop. Don't change. So I'm going to put a $sign in front of that 4. Okay. So you see the $sign in front of the 4. And now I'm going to click and drag, do a formula drag down like that. And it worked. It's K4, $sign 4. It's still $sign 4, still $sign 4, still K4, still K4, and so on. That $sign stops the 4 from changing. Okay? Now you got to be careful. There are two parts to the address. There's the letter and the number. Here it was the number that was changing, and we did not want that number to change, so we put the dollar sign in front of the number. A common mistake that's made is, let's go back here. Let's get rid of that dollar sign. And you know, without the dollar sign, it doesn't work. Okay? Some people will say, oh, I don't want this address to change, so I'm going to put the dollar sign in front of the K. Well, the problem is that if you put the dollar sign in front of the K, what you're telling the spreadsheet program is don't change the don't change the K when you drag. But it's the 4 that's the problem. Okay? So you're just freezing the K. You think of the dollar sign as kind of freezing the letter or the number that's immediately after the dollar sign. So the dollar sign freezes the K, but it wasn't the K that was the problem, it was the 4. And so if I drag this down now, it still doesn't work because K doesn't change, but the 4 is allowed to change. The K doesn't change, the K isn't allowed to change, but the 5 is. The 4 became a 5. And it becomes a 6, becomes a 7, becomes an 8. So it's not the K that's the problem. So putting the dollar sign in front of the K doesn't make a difference. What you need to do is you need to put the dollar sign in front of the 4, because that's the problem. Okay? And so you want to make sure that you get that right, like that. Okay? So now when you click and drag down, it works. All right? There you go. Okay. Now let me show you that over here. Okay. So suppose we wanted to calculate scroll too far. Okay, there we go. Suppose I want to calculate the sales tax here. So sales tax, like that. So now here I want the sales tax for January. So this one was like the sales tax for the CPUs over all 3 months. Here I want the total sales tax for January. Okay, and you say, well, how do you do that? Well, it's like the total sales multiplied by the percentage, the 8% there, like that, and there you go. There is the sales tax for January. Okay, now click in the input line there, like that, and you'll see the two pieces that go into it. There's C11, which is the total sales, multiplied by K4, which is the 8% sales tax. Okay, well, I think you can imagine what's going to happen when I do a formula drag there, across there and there, like that. We get zeros again, and you kind of know what happened. Here it's K4, but when I drag it 1 to the right, it becomes, whoops, I hit the wrong key. It becomes not, because I'm dragging across columns, the K4 becomes L4. And you say, well, what's an L4? Well, guess what's an L4? A blank right here. Okay, so you can see here there's a blank, and so L4 is 0. Okay, and it's even worse the next one over, because over here it's M4. Okay, and so now because I'm dragging across columns, the K4 is correct, but now it becomes L4, and so the K became an L, and that's wrong. We wanted to keep the K a K, and then over here it became an M, and we wanted that M to be a K. The 4 is okay, so this time it's the number that's okay, it's the letter that is not okay. And so you go back to the formula here, all right, C11 times K4, and you go, oh, when I drag this to the right from one column to the next, it's the letters that are going to change, but I don't want the letters to change, and so I'm going to put a dollar sign this time in front of the letter, like that. So take a look. So there it's the K that you want to freeze. And now if you drag that across the columns, it gives you the right answer. Because the K4 became an L4, but now because there's a dollar sign in front of the K, it froze the K and the K did not change. Okay? So when you're dragging across rows and the number's changing and you don't want the number to change, you put a dollar sign in front of the number. When you're dragging across columns and it's the letter that's changing and you don't want the letter to change, then you put a dollar sign in front of the letter. Okay? Let me say that again, because I agree this is a little bit subtle. Okay? So when we were here, we were dragging down. We started up here for like CPUs and we were dragging down. So we were dragging across rows. Okay? dragging across rows. When you drag across rows, it's the number that changes. So that was that 4 that was changing to 5, 6, 7, and so on. But we did not want the 4 to change, because then you would be like looking at these numbers over here, which are blank. You didn't want the number to change. So if you're dragging across rows and the number is changing, but you don't want the number to change, put a $sign in front of the number. All right. Over here, it was the other way around. Here, we were dragging across columns. When you drag across columns, it's the letter that changes, and we didn't want the letter to change, because then we would be, picking up L and M, and there's nothing in L and M, okay? So we wanted the letter to stay K, and so we put a $sign in front of the K, and that prevented the K from changing. All right? So in summary, what happens is when you put an address inside of a formula and you drag across rows, the numbers change in the addresses. When you put an address in a formula and you drag across columns, it's the letters that change. Now, most of the time, you want the numbers to change or the letters to change. But if you run into a situation where the number is changing, because you're dragging across rows and the number is changing, I don't want that number to change, put a $sign in front of the number. And then sometimes you're dragging across columns, but you don't want the columns to change, okay? And so you don't want the letters to change for the columns, you put a $sign in front of the letters. All right? What if you put a $sign in front of both of them? Well, sometimes people, when they're not sure whether to put the $sign in front of the number or the letter, they say, I never want it to change. I don't care where I drag this thing. I don't want the number to change. I don't want the letter to change. I always want to reference K4. Why? Because look at that. The sales tax, percentage sales tax, is always in K4. So I don't care if I drag across rows. I don't care if I drag across columns. I want it to change. I want neither the letter to change nor the number to change. You can put a $sign in front of both of them. Okay? And now, of course, this won't change. The K4 won't change if you drag across columns. It's not going to change. Okay? But neither will it change if you drag it across rows. Okay? So that's always the safest, but it's a little bit of an overkill, because you don't really have to put the $sign in front of the number here. The number will not change as you go from column C to column D to column E and so on. All right? So, all right, there you go. Okay, so the last thing we're going to study are Booleans, okay? So Booleans by themselves are not that useful, okay, because they're just like this true and false value. And you say, well, what can I do with that? But true and false are useful for making decisions in spreadsheets, okay? And an example of this is like comparing a couple of numbers and saying, is one number bigger than another number? Is another number equal to another number? Like, how does this work? And depending on whether one number is bigger than another, a spreadsheet can do one thing versus another thing, okay? And that's a little bit more sophisticated than just a regular calculator. That's basically a calculator which has some programmable decision making associated with it, okay? And spreadsheets are actually programming languages, although they don't really seem like it, but they are. There's a little bit of a programming language behind them. And so you might wonder, okay, well, how do I make use of this, okay? So let's go back to our spreadsheet here. And let's create a new sheet. Let's go to that new sheet, and let me just type in a simple formula here. I won't even make uses of addresses or anything like that. Let's just say equals, all right, like that, because all formulas begin with equals. And then let's just say 3 bigger than 4. Okay, and already that looks weird. You go, well, what does that even mean? Okay, so ignore the equals, because again, that's just how you tell a spreadsheet that what comes later is a function. Okay, so just concentrate on that 3 bigger than 4. That's like a question. Don't think of it as like an assertion that 3 is bigger than 4, because it isn't. Think of it as a question. Is 3 bigger than 4? Okay, because the sign here, the greater than sign, is asking, is 3 greater than 4? So is that true? Is 3 greater than 4? Well, if you think about it for a minute, 3 is not bigger than 4. So the answer is false. Okay, and there you go. So what this function did is it didn't actually like assert or make 3 bigger than 4, because you can't make 3 bigger than 4. But all it did was it said, look, this is a function, and I want the answer to the question, is 3 bigger than 4? And the answer is no. 3 is not bigger than 4, so you get false. Okay. Well, what about is 3 less than 4? So you go it equals 3 less than 4. And now basically what you're asking the spreadsheet is 3 less than 4? Is it? Is 3 less than 4? And the answer is yes, it is. Okay. And so you get true. Okay. And so now if you think about this, there's a whole bunch of different comparisons that you can make. You can say, is one number bigger than another number? Okay. So is 3 bigger than 4? Is 3 less than 4? Okay. Is 3 equal to 4? Like that. Now that looks really weird, doesn't it? Is 3 equal to 4? But, you know, just think of it this way. That first equal sign, it's just saying this is a function. And the function is, the question, is 3 equal to 4? And the answer is, no, it isn't. 3 is not equal to 4. Well, is 4 equal to 4? Is 4 equal to 4? Well, yes, it is. Okay. And so then there's the other possibilities. Is 3 bigger than or equal to 4? Okay. So the answer is no, it's not. Okay. And is 3 less than or equal to 4? And the answer is yes, it is. 3 is less than or equal to 4. And then the final one is 3 not equal to 4? Okay. Now that one looks weird, but that's basically how you do the not equals. It's like basically a greater than and a less than sign. Okay. Whoops, I made a mistake here. Let me X out of that and let me try that again. So is 3 not equal to 4? And the answer is true. Okay, 3 is not equal to 4. Okay, so you've got all possibilities here. Let's go through them again. Is 3 bigger than 4? Is 3 less than 4? Is 3 equal to 4? Is 4 equal to 4? Is 3 greater than or equal to 4? Is 3 less than or equal to 4? And is 3 not equal to 4? And the only other thing I want to point out is the question of greater than or equal to. So if you have, let's go back to this one. If you say, is 4 greater than 4? The answer is false. Okay, let's get rid of all these because I think we went through them already. So is 4 greater than 4? Well, 4 is not greater than 4, it's equal to 4. So of course that's false. But if you ask the question, is 4 greater than or equal to 4? Well, it's not greater than, but it is equal, and so that one's true. And so the difference here is, you know, the greater than is strictly greater than. So is 4 strictly greater than 4? And the answer is no. This one is 4 greater than or maybe equal to 4? And the answer is yes. Okay, so there's just a little bit of subtlety between the two. So let me just write over here what these operators are. Okay, I'll just write them in as text. There's the greater than operator. There's the less than operator. Greater than or equal to, less than or equal to. Equal to is just a plain old equals, or the not equals to. Okay, so there are 6 ways of comparing two numbers, and you say to yourself, okay, so what? Like, what would I use this for? Okay, well, let me show you. Let me get rid of all this. I'm just going to delete it out of this sheet here. Let's say that there's a bunch of grades, okay, and let's do a course which is just basically like an SU course. Okay, so SU courses are like, you know, you don't get like grades like A, B, C, D, or anything like that. All you get is an S if you're above 65, or you get a U if you're below, if you're 64 or below. Okay, so S stands for satisfactory and U is for unsatisfactory. Okay, so if you've got like some numerical grades here, so let's do like 87, 76, 55, 65, 64, 78, and then 22, like that. Okay, okay, so over here, if you ask the question, so we'll put up here manually, or actually I'll do it over here, manual. So like we're going to go through all these numbers and we're going to manually assign a letter grade. So you ask yourself, okay, 87, is that a satisfactory or unsatisfactory? It's satisfactory. Okay, 76 is satisfactory. Okay, 55, that's unsatisfactory because it's below 65. Okay, it's 64 and below. Okay, 65 is satisfactory. That's right at the edge. Okay, 64 though is unsatisfactory. Okay, so 64 is unsatisfactory. 78 is satisfactory and 22 is unsatisfactory. Okay, so we did that manually. We manually typed in S and U. Okay, and that wasn't so bad because it was like, you know what, 2, 4, 6. So there's like 1, 2, 3, 4, 5, 6, 7 grades there. Okay, so it wasn't so bad. But suppose that we want the computer to do this, okay? So what we can do over here is we can type in a function which is actually a Boolean based function. This is a function which makes use of a Boolean. So let's do that. The function name is called if, okay? And it's just like the English word if. If one thing is bigger than another, if something is true, then do one thing. If it's not true, then do something different, okay? And so let me say that again. So there's three parts to the if function. The first part is you're going to check something. Is something true or not? Okay? If it's true, then you do one thing. If it's not true, in other words, if it's false, you do something different. Okay? So there's three parts, and the three parts are actually separated by commas. Okay? So what you're seeing there is actually the if function. This is a comma there, and there's another comma. Okay? Now I'm missing the part that goes there, I'm missing the part that goes there, and I'm missing the part that goes there. Okay? So there are three things that I have to put in here. The first thing is a comparison. So what comparison do I want to make? I want to take that grade 87, but I'm not going to type in 87. I'm going to put the cell address, which is D4. Is D4 bigger than or equal to 65? Okay, so take a look at what I just typed there, that part right there. Okay, is D4 bigger than or equal to 65? Well, if it is, if D4 is bigger than 65, then print out S. Now the quotes around that means just print out S. Okay, so if D4 is bigger than 65, if you're bigger than or equal to 65, then you got a satisfactory grade. Okay, well, if you didn't get a satisfactory grade, what did you get? You got an unsatisfactory grade, like that. Okay, and so what you're seeing here is basically an if function. The first part of the if function is one of these comparisons that we've been doing. And the comparisons will either be true or false. Okay, so the part that's highlighted, it's either true or false. It can't be maybe, it can't be halfway in between. It's either true or false. If it's true, then you're going to do this. You're going to print out an S. If it's false, then you're going to print out a U. Okay, so you can't ever print out both an S and a U. Either you're going to print out an S if this is true, or you're going to print out a U if that is false. Okay, and so you could see that the if function is basically a decision-making function. Okay, it's going to decide whether something is true or not, and then print out an S or a U. Well, as you expect, let me bring this in closer here. It prints out an S because 87 is satisfactory. But now we don't have to retype that function over and over and over again, right? What do we have to do? We just have to do a function drag down, 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 down like that, and then hit enter. And look at that. We now generated automatically what we had determined was the grade manually. So 87 turned out to be greater than or equal to 65, so you got an S. 76, the function said D5 is bigger than 65, okay, because 76, the D5 there gets replaced with the 76. Is 76 bigger than 65? Yes, print out an S. So I printed out an S, okay. Over here, it said D6. Well, D6 is 55. Is 55 bigger than or equal to 65? Well, no, it's not. And it prints out a U. And so I printed out a U. And then 65. Is 65 bigger than or equal to 65? Well, yeah, it's equal. And so it prints out an S. Over here, it said D8. D8 is 64. Is 64 bigger than or equal to 65? Well, no, it's not. And so it skips the S because that's for true, and it does the U because that's for false. And so you could see that it's going to print out an S or a U depending on whether this grade over here is bigger than or equal to 65 or not. Okay? And so that's how your if function works. All right, let's apply that to another example here. So what I have here is basically just taxes, like you're going to calculate income tax. Okay, and so we have 5 people here. We have Fred Flintstone, Wilma Flintstone, Barney Rubble, Betty Rubble, and Pebbles Flintstone. Okay, and this is how much money they make. All right, a year. I guess it's not a lot of money, but we'll just pretend. So, you know, Fred Flintstone makes $37,500 a year. Okay, Wilma makes $39,000. Barney makes 19. Betty makes 21, and Pebbles makes 43. Okay, so I have 2 ways of calculating the taxes. Okay, let's do method number 1 because this is the easiest one. Okay, the way that works is by this scheme right here. So basically, what you want to do is if you are under $30,000, you're gonna pay 0% taxes. Okay, so for instance, Barney here only makes $19,000 a year. That's less than 30,000. Okay, so if you're at 19,000, that's less than 30,000. Well, then you don't pay anything. Okay. But if you're like Fred makes 37.5, well, that's bigger than 30,000 there, and you pay 5%. Okay, and so over here we're going to put in a function. Let me just spread that out so it's easy to see. We're going to put in a function, and we're going to go 8 equals if. So just like we did a minute ago, and then we're going to take Fred's pay here, which is C5. It's in address C5, and we're going to say, is that less than 30,000? Like that. Okay. And by the way, when you type in the numbers into functions, don't put any dollar signs or any commas or anything like that. Okay. Just put in the numbers straight. Otherwise it gets confused because it doesn't know whether you want the comma for the number or the comma as a delimiter between the arguments of the function. Okay. So remember, there's commas which separate the three parts of the function. So if you put a comma in the number, it gets confused. Okay. So just write 30,000. Okay. Don't put the dollar sign. Don't put the comma in there. Okay. And if it's less than 30,000, well, then you're paying 0%. But if it's bigger than 30,000, then you're paying 5%, and that's 0.05. Okay, like that. Okay, so 5% is 0.05. Okay, and so if I hit enter now, you will see that Fred has to pay 5% in taxes because Fred's pay is over 30,000. So what it's doing here is it's saying C5. What's in C5? Well, 37,500. Is 37,500 less than 30,000? Well, no, 37,500 is bigger. And so it skips the 0 because that's what you would get if it were true, but this expression is false, and so it prints out the 0.05. Okay, and let me shrink that back down. Okay, so what about for the other ones? Well, for Fred, above 30,000, so it's 0.5%. Wilma, above 30,000, 0.5%. Barney is below, so 0. Betty's below, so 0. And Pebbles is above, so 5%. Okay, and there we go. That's how the taxes according to scheme number 1 are calculated. Okay, let's go to scheme number 2 because this one is more interesting. It's a little harder. Okay, and this is about as hard as I'm going to make them because the logic here gets pretty demanding. Okay, once you're used to it, it isn't too bad, but for the purposes of this course, we won't go any further than this. What if you have 3 possibilities? Okay, and you say to yourself, geez, how can I possibly work with 3 possibilities? Because the if function just has 2 possibilities. Remember, if this is true, okay, if the highlighted area is true, then you print out 0. If the highlight area is false, then you print out the 0.5. And you say, well, that's only 2 possibilities. How do I deal with 3 possibilities? Because this scheme, okay, this is tax scheme number 2. Let's call it taxes 2. Okay, like this. Tax scheme number 2. In tax scheme number 3, there's 3 possibilities. If you're below 20,000, you pay 0. If you're between 20 and 40, you pay 2.5. And if you're above 40, you pay 5%. And you go, wow, how do I deal with that? Well, this is where it gets a little hard, but let me see if I can explain it to you. You can always break up any complicated decision into a series of binary decisions. Binary decisions meaning a decision between true and false. So how do you apply that? How do you make that work? First, you check if you're below 20,000. If you're below 20,000, you know that you pay 0%. If you're above 20,000, you're either going to pay 2.5 or 5. Okay? So rather than trying to do the whole thing at once, let's do it just one step at a time. How about let's just first decide if you're below 20,000, you pay 0. So over here you go equals if, take the pay, C5, and ask, are you less than 20,000? Well, if you're less than 20,000, what do you pay? 0. Okay, that's what this says. If you're below 20,000, you pay 0. If you're above 20,000, what do you pay? I'm just going to put a question mark there. You see, why'd you put a question mark? Because I don't know. Because you might pay 2.5% or you may pay 5%. Okay, so right now I don't have a full answer, but I have a partial answer. If the value, if the pay, C5, is less than 20,000, then 0. But if it's above 20,000, I'm still not sure. Okay? Do you see the logic? I'm doing a divide and conquer. I'm taking care of 20,000 first. Am I below 20,000? Yes, 0. Am I above 20,000? Yes. Well, then I got to do something more. Okay. So what you'll see here is that for Fred, I got a question mark. Okay. Let me put the question mark in the middle here, just so it's a little easier to see. Okay. So I got a question mark for Fred because Fred is above 20,000. Okay. So Fred doesn't get a 0. Fred gets either one of these other two. Okay. What about Wilma? Well, Wilma also gets a question mark. What about Barney? Barney gets a 0 because Barney is below 20,000. He's at 19. Okay. What about Betty? Well, Betty's above the 20, so she gets a question mark too. And Pebbles is really above the 20,000, so also another question mark. So you have only a 0 for Barney because Barney is below 19,000. Okay. Now we haven't fully answered the question, but at least we've gone as far as eliminating everyone that's below 20,000. Let's go back to this and take a look at what we have to do next. So the problem right now is that question mark. Okay. So let's expand this out. I'm gonna put a lot of space in there. We got to put something in there, which is 2.5 if it's between 20 and 40. And 5 if it's above 40. And so what you could say is something like this. Well, you know what? If it's above 40, I know it's 5%. So over here, I'm going to go, okay, if the amount here is above 40,000, we know that it is 5%, 0.05. Okay? But if it's not above 40,000, then it must be 2.5%, 0.025. Okay? And you say, well, wait a sec. Why didn't you put in there 0? Well, because if we get to the second if, okay, if we get to the second if, then we know that we're not below 20,000, because if we were below 20,000, we would have ended at that 0. So the mere fact that we get to this third part of the first if, in other words, we get into the second if, so this is an if within an if. If we get to that second if, we know that we're above 20,000. So there's only two possibilities. Either you're above 40,000, in which case it's 5%, or you're below 40,000 and you have to be above 20 because we've eliminated that possibility already. And so that must mean that you're at 0.25%. Okay. And now you could see that for Fred, you got 0.025. For Wilma, you're going to get 0.025. For Barney, you still get 0. For Betty, you're going to get 0.025. And for Pebbles, you're going to get 0.5. Okay, and just to make these look right, I'm going to actually do the little percent there. Okay, so there you go, and then get rid of some of the decimals. Okay, so there you go. So did it work? And we'll go back and I'll try to explain it. I agree that this is really hard to get your head around, but I want to show you how the logic works. But first, did it work? If you're below 20,000, you're a 0. Well, if you go through these, the only one that's below 20,000 is Barney. So Barney's the only one that gets a 0. Okay. Now, if you eliminate Barney, all you have to check next is, are you below, or are you above 40,000? Because only the person that's above 40,000 gets 5%. And you go through here and you go, okay, is anyone above 40,000? Only Pebbles. So only Pebbles gets the 5%, and only Barney gets the 0%. Well, everyone else has to get to 2.5 because everyone else is going to be between 20 and 40,000, which gets to 2.5. And that's exactly what I did with the if function. Okay, so let me try to spread this if function out a lot. Okay, so these spaces are not necessary. Okay, they're not necessary, but I'm putting them in there just to make it easier for you to see what's going on. Okay, so the first thing you check so you do the first if first. Okay, so there's this if statement right here. Okay, that's the first one. That's the outer if. So this is like, they're called embedded ifs, one if within another. And you first check, are you below 20,000? Well, there's only two possibilities. Either yes or no. If you're below 20,000, print out a 0 and you're done. Okay, if you're below 20,000, print out a 0 and you're done. If you're above 20,000, well, then you got to do some more checking. Okay, you got to do some more checking. Whoops, I accidentally put in a, okay. So if you're above 20,000, you got to do another check. And what's that other check? Well, you know you're above 20,000, otherwise you would not have even gotten to that if. So you're above 20,000 already. Now check, are you above 40,000? Okay, so the second check is, are you above 40,000? If the answer is yes, then print out 0.5. Well, if you're not above 40,000 and you know you're not below 20,000, then you must be between 20 and 40,000, and that gives you the 0.25 there like that. Okay, that part there like that. All right. Whoops, I accidentally moved some stuff around. Okay, I accidentally drag. There we go. There we go. Okay, so the only way you can get to that 0.25 is if you're not less than 20,000 and you are not above 40,000. So you're not less than 20,000, you're not above 40,000, then you must be between 20 and 40, and that's the only way you can get to that 0.25. Okay, if you're less than 20,000, you would have ended up at that 0. If you're above 40,000, you would have ended up at that 0.05, and so that's the last remaining one. So basically what you're doing is you're eliminating one possibility at a time. Okay, so first you eliminate the possibility of being below 20,000, because if you are below 20,000, you print out 0, and you never get to the second if. If you're below 20,000, you never get to the second if. You just get this far, you get to there, you print out the 0, and you're done. But if you're above 20,000, then you get to the second if. So if you're at the second if, you're above 20,000. Okay? Well, you're above 20,000. Are you above 40,000? Well, if yes, then print out 0.5. If you're not above the 40,000, then you're below 40,000. But you know you're above the 20,000 because you got to the second if. And so if you're not above the 40,000 and you know you're not below you're not below 20,000, then you must be between 20 and 40, and that's your 0.025. Okay, and that's how you get this percentage there like that. So if you just drag it across there, you see that you've got three possibilities: either you're 0, 2.5, or 5. Okay, now I agree that's kind of hard. I just wanted to show you that it is possible to actually take care of three possibilities here. And you say, well, how do I do three? Because with two, it's easy. Either it's true or false. Okay, so either you're above 30,000 or you're not. In which case, if you're below 30,000, you print a 0. If you're above 30,000, you print 0.05. Okay, so that was easy. But if you've got three possibilities, say what do you do? You eliminate one possibility at a time. So check. Are you below 20,000? Yes, you're done. No, well, do another check. And by doing one check after another, you can do multiple possibilities, but each time you're breaking it down into a series of binary possibilities. Okay, and so this is what's known as a divide and conquer algorithm. And I did want to show you that this was possible, although I have to admit students do tend to find this a little bit difficult. So on a test, I would be very gentle with respect to the if function. Okay, at the very least, you must be able to understand how it works with just a binary possibility. Okay, so here's a binary possibilities. You should know that if this is true, if it's true that C5 is less than 30,000, then you'll print out the 0. Otherwise, you'll print out the 0.05. Okay, and that's it for what we're going to study with spreadsheets. Okay, so admittedly, spreadsheets can be very demanding. Okay, and you may have to actually watch this video, or at least parts of this video, a couple of times, because I can understand how, even though I went through this and I explained it to you, you may not have seeped in the first time. And this is probably the most difficult part of the whole course. People think that the gates and all the electronics at the beginning are. I think that the spreadsheet is probably the most difficult part. And I've everything that I just explained here, it's also in the summary notes, and it's one point at a time. I broke up the summary a little bit more than I usually do. Okay, so make sure that you understand all those points, and ask any questions if you have any and that you didn't understand. Okay, all right, bye-bye.